Hello everyone, I am PS Vivek Raja and welcome to today's session Zero to Hero Image Processing Techniques Part 1. So, Zero to Hero Image Processing Techniques is a two-part series and we'll be trying to cover the concepts of image processing from the basics and we will try to efficiently build image processing algorithms in TensorFlow in next session. So in this session, we'll be actually concentrating on all the basic topics that and the concepts you require to know about image processing, and we'll also try to build a simple algorithm on that. And in second part, we will progress and make a very efficient machine learning algorithm for your image classification. So I hope you are all having a good evening today, and this will be available as a recorded video in the YouTube channel, as well as you can also join us on the second part where we'll be discussing on the advanced techniques of the same part on the series. So about me, I'm from Madurai, Tamil Nadu. I have graduated from Link Engineering College in 2020. I'm currently working as a data scientist in a startup called NexStem, where we build brain-computer interfacing and stuff. So I am currently AWS Machine Learning Hero, which is as part of the Heroes program recognized from AWS around the world. I'm also organizing Azure developer communities in Tamil Nadu, which is running over with 3,000 plus members. I'm a co-organizer and a member of all AWS user group, TensorFlow user group, GDZs, and Tamil FOSS community. I'm 16 times multi-cloud certified from Microsoft Azure, Oracle, and Alibaba. I'm a Microsoft certified data scientist, AI engineer, data engineer, and developer associate. I'm also Oracle Cloud Solutions Architect, as well as Alibaba Cloud Expert. So besides this, I love participating in hackathons. I've won around 20 plus hackathons the last 3 years, and I published around 5 research papers. And one of the one patent is currently in evaluation. And I'm an active speaker, mentor, and a blogger in terms of AI and cloud, and also contribute to open source. And this is my GitHub link. So let's dive into today's session. So before we go into that, I would like to explain how we are going to take this two-part series to master image processing techniques. So the overall series will be covering these in 4 broad steps. So which is like we'll first learn about what is image processing and the use cases which is associated in this real world. Then we will understand what are the challenges which are currently existing in image data processing. And with that challenges, we will be trying to address those challenges and try to do image data processing. And we'll understand what are the workflow which is involved in it. And of course, we'll try to learn everything by hands-on. So there is a necessity of learning few theory parts and concepts, and we will try to implement that in coding to make sure that we understand and learn it much more better. So today is part 1 of Zero to Hero Image Processing Techniques series, and this is brought to you by GDG Mysuru and TensorFlow User Group Mysuru, as well as Women Tech Makers Mysuru, along with the industry partners, JetBrains, as well as Iris Lab AI. So let's dive into today's session. So first we will try to learn what does image processing or image data analytics look like. So a formal definition looks something like this. So image processing or image data analytics is a field of knowledge that falls in computer vision. So if you take artificial intelligence as one domain, there are multiple subdomains or subset which is along with that. So which is considered machine learning, deep learning, computer vision, or some of the subdomains of artificial intelligence. So image processing is a subset of computer vision if put into simple words. So it is actually nothing but a whole set of techniques and processes that is used to analyze imagery data and extract valuable information. For example, let's take a simple use case. So there is some words written in your or letters or digits written on the screen, and you're trying to capture that and see what your machine learning algorithm says and what number or alphabet is that. So you might have used captcha and so on. So how does it really understand that the letter in the form of 2 is actually a digit which is representing 2? So we will try to understand how machine learning algorithms tries to learn those imagery data and how we can help that machine learning algorithm to learn it much more better to give better results. So what is the purpose of learning or creating these stuff? So the first the intended purpose is to reconstruct a complex and colorful three-dimensional world. So for example, if let's take another example like a self-driving car. It has to understand the whole world which is running beside it to make sure to take concrete decisions and real-time decision to make sure that it can drive a car in a safe manner. So this is the ultimate purpose of what we are going to use image data analytics. What are the operations which is involved in image processing? The first step is pre-processing. As you know, like if you take any data in the real world, it is of course mixed with impurities or missing values, or it might not be the correct data or the image to be directly fed into a machine learning algorithm. So of course, so we have to do something to make sure that the image are standardized and balanced so that we don't introduce any bias in terms of anomalies and so on. So the first step to prevent that is to do pre-process the images. So what are the operations which is involved in pre-processing is like we try to correct the exposure, we try to balance the colors, and so on. So this is actually enables that your model gives a better results at the end. And now that we understood like what is really image processing and what purposes does it serve, and of course like what are the steps which is currently introduced before we actually dive into image processing. So now that we know that, we can try to address like what are the use cases which is currently existing in the real world. So one of the major domain where we use image processing is in medical imaging. So in medical imaging, scientists try to understand the inner structures of tissues, algorithms, and so on. So that can help them to process and identify the anomalies. So even one of my research paper was based on how to count the cancer cells present in a medical image. So that involves extensive number of pre-processing and involvement of many deep learning models to give the best results. And security. So you might actually seen so many CCTV cameras which is installed even in our houses and in streets and so on. And there, suppose you encounter a burglary or thieving or some accident which is going on, then you go back to your CCTV camera to review that footage, right? So what if your CCTV camera or your footage is intelligent enough to identify something which is happening in real time so that you'll be able to uh, get those security measures done immediately? For example, like what is the purpose, like if the robbery is completed, we have to stop the robbery. That's the main purpose, right? So what if your CCTV cameras are intelligent enabled that it can identify that a robbery is going on based on some inputs? So which involves like all these security or these kind of activities involve usually in night. So by night, what I mean is like we have very low exposure and there is a very less brightness. So your cameras must be intelligent enough to identify that you have to overcome these stuff to analyze what is really happening there. So of course you have to increase the brightness and make sure your exposure is right so that we can understand what is really going on the other side. And general image sharpening and restoration. This is one of the amazing use cases which I usually love about. You might have seen a lot of Instagram posts or an article saying that we have colorized or restored historic images and so on. So actually, image processing plays a vital role to do that. So that's where your machine learning comes into picture, where you can do sort of colorization and restoration as well. One of the simplest example is your filters which you use in Instagram or Snapchat. So if you're a Snapchat user like me, or if you do use Instagram on regular basis, what you have to do is just go to your camera and try to apply any filter. And in and that filter, for example, there is a dog filter, which means like whenever you open a mouth, that pops out a big tongue, and also you keeps dog ears on your head perfectly, right? So how does it really happen? These are the end results or outputs of an extensive machine learning algorithm which is running on behind the screens. So it tries to analyze where your face is, And once your face is analyzed, like it tries to keep those dog ears on the top of your head by marking some landmarks. And once you open your mouth, which is a sign that a trigger has happened, that's where it gets replaced with a dog tongue to do the necessary action. So this is how every single filters of ChapNet actually works behind the screen. So now that you know like something that is happening behind uh, the screen while you're using a filter, so when the next time when you open it, you can just remember that there is a huge number of developers who have put up a lot of efforts to do something which is amazing, that we are using it every single day. And military and defense actually plays a very, very vital role. So to analyze if there is any uh, uh, attacks are going on, or maybe one of the interesting use cases is steganography, is like where they try to hide the information within images. So this is one of the oldest as well as one of the frequently used method, where they pass images but they try to secretly embed messages within that particular image. So this is called steganography, and image processing plays a vital role in that. So now that we actually understood what is image processing in the first place, what a definition looks like, and we try to break down the definition and learn that what is actually image processing says about. And we also learned about like what are the operations which is involved in it, and what is values or use cases that is served in real time world. So, with that all being said, what are the challenges that an image processing undergo? Because this is a subdomain of a huge learning space, which is artificial intelligence. Of course, processing an image do involve a lot of challenges, and we'll try to address them in this one. So, first one is intra-class variation, and second is scale variation, viewpoint variation, occlusion, illumination, and background clutter. So let's try to understand each one of the challenges in detail. So intra-class variation is about and a variation of the between the images of same class. For example, let's take you're trying to classify furnitures. So a furniture may be like a table, chair, or whatsoever. And if you just give up all like images of a lot of images, like for example, all your household items, and you have to classify whether that is uh, a furniture or not. Of course, even a chair is a furniture, but if it that can be categorized even more better, right? So that is a chair and a table. So these are the interclass variation, which is between the images of same classes. That's one of the problem. And scale variation is about, for example, if you keep the same object in multiple sizes, what if your machine learning algorithm is able to detect that? And for example, if you keep a water bottle nearby you, or if you keep a water bottle very distant in a small resolution, your machine learning algorithm should be able to identify that. So that's scale variation. And viewpoint variation is like, it's not necessary that all the images should be always placed in a current viewpoint. For example, like if you're trying to identify a water bottle in an image, it is not necessary to be as straight as possible. It can be on different viewpoints and so on, so and everything. So with that being said, it must be able to identify in so many views and angles, so that the correct object can be classified or identified in real time. And occlusion is like, there assume like there is a lot of objects which we want to classify an image, but they cannot be viewed completely. That is, a large part is hidden behind some object. For example, like again, let's take the water bottle as an example. But before the water, like in front of the water bottle, there is a huge cat which is sitting in front of it. So it has almost hidden our primary object which you are trying to classify, which is identify, which is the water bottle. But if your machine learning algorithm is able to identify that, even if a small part of the object is visible, it must be able to identify that. So that's called occlusion. And illumination is the brightness which needs to handle. And background clutter is about how noisy that image is. Like there might be a lot of unnecessary or semantic understanding which is not required for that particular image, but you still want to go and identify it. So we need to remove those background clutters so that we can focus on the image which we are trying to identify. So these are the challenges which we are trying to address here. And if you do have any questions, keep posting that in the chat box and I'll revert to you right away. So just give me a second for it. Yep. Now let's continue with our next topic, image processing and data analytics workflow. So if you take any machine learning process or anything that involves a lot of steps which needs to be undertaken, that is where you follow a procedure to make sure you achieve an end target. And let's see like what is the workflow that you have to carry on to make sure that you can carry out an image processing problem from end to end. So I can broadly say that these are the steps which needs to be involved in a particular workflow, which is identifying the data sources, creating and organizing the data sets, loading the data set, pre-processing the images, data augmentation, training the machine learning models, and fine-tuning the models. So in this session, we'll be actually trying to address every single workflow so that we'll be able to follow the same to achieve our end target of doing a proper image classification or processing problem. So before we actually get started with hands-on, but let's try to understand each step in a detailed way. So the first is identifying the data sources. So if you're going to solve an image processing problem, first you need to collect the data because you can't work without any data for any machine learning problem. So what are the common sources where you can find the data sets are in Kaggle, UCI. You can also find it in research institute data sets like Stanford. There are a lot of pre-compiled datasets, for example, like CIFAR 10 and so on so. And even TensorFlow provides a lot of datasets in form of TF datasets. And if you're trying to solve a peculiar problem, you can collect your own dataset by capturing images, which is a self-compiled dataset. So now that you identify the data source, now we have to create the datasets. So what you have to do is you have to first identify the dataset, you have to copy and load them into your machine learning workspace. So what I mean by machine learning workspace is like where you're currently working. It might be your Google Colab or your local system, or it might be any cloud IDs or whatsoever. And the second thing is usually when it comes to classification problem, we try to classify those images and keep it in the folders which represents the class. For example, like if I'm trying to classify different types of furniture, I would capture different images of furniture, for example, like table, chair, teapot, or whatsoever. And I try to capture as many images and I will organize that in terms of class names to able to make sure that I can read and access those images easily and help machine learning problem identify that as well. Suppose if you're using a large number of data set, for example an online data set, you can refer to the dataset URLs probably in Kaggle and so on so. And instead of downloading the whole images in one go, there is always batch wise loading and downloading to make sure that you can optimize the storage and the cache of your temporary memory while you're using the same. So now that we have understood like something, what are the workflows that needs to be done, let's try to do a simple image classification problem and then come back and analyze what are the steps we undertook, and we will try to learn them in detail. So before going that, first we learned about how to identify and collect the data set and organize it. So that's the first step. And then we will try to now understand of doing the image pre-processing and training a simple machine learning problem, classification problem, and we will try to understand the complete workflow in there. So let me switch back to our code flow. I'm going to use a Google Colab, and if you don't have one, you can just go to your drive and spin up a Google Collaboratory, and I will also share the source code at this end of the session. So you can just sit back and enjoy the session, and you can come back to the coding parts later when you're free. So in this, what you're going to try to do is a basic classification. We will try to classify the images of clothing. So this is the problem we are going to now trying to solve, and I have already run the whole collab so that I can save the time in running it, but you can always take back the source code and run it whenever you're free. So this is actually a guide to train a neural network where we're going to classify clothing like sneakers, shirts, trousers, and so on. And we'll use TensorFlow for that. So let's import all the necessary uh, um, libraries for it, and then we will try to import the dataset. So the first step is to identify and collect the dataset. So we have identified to use a fashion MNIST dataset. So it's the fashion MNIST dataset is about 70,000 grayscale images of 10 different types of clothing, and each article of clothing is at low resolution. Like for example, it's now we have set it as 28 cross 28 to just view the whole data set into one go. So let's try to load the dataset. The TensorFlow dataset itself has the fashion MST. I'm going to load it. I'm going to also load the data in forms of the train images and the labels, and the test images and the label. So if you don't know what I'm actually doing here is like, we have to always split the dataset into training and testing part, so that we will train the machine learning model with the trained with a training dataset, and we'll try to evaluate the model to see how well a model has learned with using the test data set. So what are the label, what does actually mean? So this is actually a cloth, and what does a cloth represent? I guess that's a shirt. This one is a shirt. So this is a trained data set, for example. So this is a trained data set data point, and the label represents a shirt. So label represents the actual class of the clothing what you're trying to solve here. So now let's load the dataset using NumPy array, and this is the label which we are going to assign. So a t-shirt or top is represented as label 0, and trousers as label 1, pullover as label 2, and so on. And this is how we'll make sure that to map that particular values to the class. Let's put it into a list. So to understand or to the deep dive into a particular image processing problem, first we need to understand the data in a much more better way. So let's try to print out the shape of that training dataset. So the training dataset is split into around 60,000 images, and each image is about a 28 cross 28 resolution pictures. And what are the labels which has 60,000? So which actually maps to it. And what is each label is between it? So it's like everything is an integer, and it falls between something before 0 to 9. And what is the test data set? Test data set consists of 10,000 images. Like, so the total is 70. We are split into 60,000 images as train and 10,000 images as test. The first thing we have to do is we have to pre-process the particular data, the images. So let's try to first print out an image to see how it looks. So this is an image of the trained data set, so which is image of 0. I'm going to use a color bar to do it, and of course you can see this is a shoe, right? What does it say? It's 9. 9 means ankle boot. Yeah, that represents as we can know it, but how the machine learning model will try to learn, let's see. The first step of any or a standard way of doing it is to normalize or standardize that particular image. So what we do is we divide the values by 255, so that if we divide it by 255, you will be able to standardize it. So this is like to verify that machine learning model can ready to build and train. We'll just display random 25 first 25 images, so which is ankle boot, t-shirt, dress, t-shirt, pullover, and so on. So now that our data set is ready and it is standardized, which is like the pre-processed, now let's try to build a model. I for now just understand like we are going to build a simple a deep learning model, but we will try to understand what each line looks in the conceptual part. So what we actually do is, in a neural network, which is a deep learning model, we say each and every block as a layer. So and each layer performs some sort of work. For example, the first layer what we had is a flattened layer, and the flattened layer takes an input of 28 cross 28. So what is 28 cross 28? It is nothing but our images, right? So what does this flatten do? It flattens all those images into a one-dimensional array rather than a two-dimensional array. So it will be like 28 cross 28 will give you 784. It will be like unstacking that particular two-dimensional array into one-dimensional array to make sure that it will be easier to learn. And the second layer is a dense layer. So a dense layer is, we'll try to understand what the dense layer looks like, and it has an activation function called relu. So and of course, like we finally appended with a dense layer of 10. So what does this 10 mean? This 10 actually represents the uh, output layer. So which means like each layer will represent one of the output class we are trying to predict here. So we'll just try to compile the model here. So when it comes to compiling a particular model, there are three steps which need to be taken care of. The first thing is model.compile. So and the steps which is involved in the model.compile is the loss function, optimizer, and a metric. An optimizer is about uh, how it actually updates based on the loss function. So a loss function is about how well you want to minimize the models, like you want to steer the model in a right direction. For example, you have to increase its accuracy, right? So to make sure that it drives into maximum accuracy and less number of miscalculations, the loss function takes care of it. And optimizer actually depends on the loss function to make sure that it is updated, the weights are updated in a right manner to get it steered in the right way. And metrics is to monitor each and every training and testing data set to make sure that it evaluates the particular run of that particular model. So now that we have compiled this model with these Adam as optimizer, loss as sparse category cross entropy, and metrics as accuracy. So we will try to understand what each and everything means in the conceptual part, but let's now we understood that a layer represents a part of a neural network, and we have used three layers here, and we have compiled the model using three things, which is loss function, optimizer, and metrics. And now let's try to train the model. So to train the model, you have to call model.fit, and you're passing the train images and the train labels, and we're going to run it for 10 epochs. So at the end of 10 epochs, what you have finally seen is the loss function has reduced, which is a good sign, as well as the accuracy has improved from 0.8255 to 9093, which is we have actually reduced the loss and the accuracy increasing, which is a good sign that model is learning in a better way. Now let's try to evaluate and see how well the model has done. So I'm going to evaluate by passing the test data set, and the test accuracy seems to be like the loss is 34% and accuracy is 87%, which is actually a very good for any machine learning problem. And you can just make a prediction by importing another layer called softmax layer, and we can predict it by this. So in the predictions, we try to predict the test images, and for example, let's try to get the first prediction, which is prediction of 0. It actually represents all the 10 values. For example, this is the probability of classifying that as a first class, class 0, class 1, class 2, and so on. So now let's try to identify what is the maximum of these values, which is the 9. So it has particularly predicted in the right way. So now what we can do is, like, now let's just assume like full set of 10 class predictions, and let's try to plot it. And this, for this particular ankle boot, it has predicted as 9, which is correct. And for this, it is predicted as 92% as a sneaker, and the class 7 as a few percent. And if you try to analyze this, these are the probabilities of how well the model has been classified. So now let's use this particular model to make the predictions as we have seen about, and using the model.predict, you'll be able to predict as we are going to see. So this is how we can actually train a model in an instant. So, but Now that we actually did some basic calculation using TensorFlow datasets, but there were new concepts which are involved in it, like building a neural network, and there are few concepts which are involved in it. So now let's try to understand that in a better way. So now that we used a basic machine learning image classification, so let's try to first summarize what you have done. Then we will learn what we have missed in that particular practicals. So first we identified the data source as the TensorFlow dataset. We created the dataset using tf dataset, and we loaded it using tf-keras.dataset.load. To pre-process the image, we scaled all those values between 0 to 1 so that it will be easier for machine learning model to learn. So we divided everything by 255, which is the RGB value, and we built the model using sequential class. We had 3 layers, which is flatten and dense, and the other values for the prediction. So the first flatten is to unstack the particular layer. So all this 28 cross 28 two-dimensional array is unstacked into one single one-dimensional array, which is 784. So once that pixels are flattened, we passed it to a dense layer. A dense layer is nothing but a fully connected neural layer. What does mean by fully connected is like each layer consists of a number of neurons, and each neuron is connected to all other neurons in the next layer. So the first dense layer has around 128 neurons, and the second layer has around 10. So which means all those 128 neurons is connected to every single 10 neurons in the next layer. So a tensor dense layer works like this. For example, this is an input, and this is uh, a dense layer. A dense layer connects to every single input of that particular previous layer and the next layer. So it is connected completely, and all these are connected to this one as well. So each neuron in the dense layer receives the input from all the neurons. It does some calculation, and then it passes down to the next layer. And now that we understood like how a machine learning model is created, now let's try to understand the compilation part. So there were three things which I mentioned. One is the optimizer, loss function, and the metrics. So now let's try to understand that. What Before going to that, let's try to understand the activation function ReLU, which is mentioned in the model, which is the dense layer slash a comma activation equal to ReLU. So the ReLU is the short form for rectified linear activation function. So let's try to do that, understand it. It is an activation function. To know what is an activation actually does is like it is responsible of transforming the summed weighted input from the node into an activation of the node or the output of the input. So for example, so the n1 receives the input from x1 as well as x2. So this is a summed weighted input, and once it is received in this layer neuron, there is some calculation which is taking place. As I said earlier, this calculation is nothing but an activation function. So what does a function do? Like a function takes up an input and produces an output, right? So an activation function takes up the summed input of all the neurons in the input layer and does some calculation, and then it returns a value to the next layer. So what does that calculation actually do? That depends on what type of activation function we choose. So in our case, we chose ReLU, which is rectified uh, uh, linear activation function. And let's try to understand what does it do. So ReLU is a short form for rectified linear activation function. So it's a linear function that will output the input directly if it is positive, or else it will output as 0. For example, if the weighted summation is a positive number, it will input it directly, or for the negative number, it will input as 0. This is one of the simplest activation function, and it works really better for many of the neural networks. And now that the model is built, now we need to compile the model. So as I said, there is 3 steps which is involved in it, which is the loss function, optimizer, and the metrics. So now let's try to decode it in a much more better way. So Before we learn the optimizer function, which is the atom, we need to understand some of the few concepts which is going into it. So what is gradient descent? So you might have any machine learning person who's just started or working in a machine learning problems might have definitely come through this term called gradient descent. So a gradient descent is nothing but an iterative optimization algorithm to find the minimum value for a function. Okay, so it's like for what we'll do is in this gradient descent is like we initialize the parameters to some random values and we take some small steps in direction of the slope at each iteration. So, and this gradient descent is actually used in supervised learning and its goal is to minimize the error function and find the optimal values of the parameters, right? Okay, so now that we know what is gradient descent, now let's try to understand the atom. So before going into that, I'll just give a brief introduction about like what is gradient descent. We know that it is an iterative optimization algorithm. So every single machine learning model has one objective, that is to predict well, right? To predict that, to make sure that it can predict well, it has to find the global minimum for the loss function. So what is the global minimum? So for example, like if there is any graph, for example, like as we say here, let's try to understand in this way. So an iterative slope looks something like this. Okay, so this is a slope and this is like for each iteration. So at each iteration something goes something like this. So this is an iteration, this is an iteration, let's assume like this. Okay, 3 4 5 6 7 8 9 and 10. So in this particular this one we have understood like this is the lowest, right, global minimum, and these are also the minimums which is not the lowest but it's the lowest not as compared to this lowest value. So which means the global minimum refers to this one and these are the other local minimums. Our machine learning model choose in such a way like it does not fall that this is the lowest one, rather it needs to choose this is a global minimum. So the ultimate step is to not fall into local minima, and its goal is to find the global minimum. That's the entire solution for any machine learning problems, as in supervised to be in general. So when we take a small steps in direction of the slope, this is the direction of the slope, and we take small steps, which is nothing but an iteration, and we try to minimize error function and find the optimal parameters to value. So for this particular global minimum, there must be like, for example, there are like parameters called alpha, beta, gamma. So we try to first randomly initialize and we find the parameters value so that it gives the local minimum. So for example, if give something like this, so which is uh, the parameters of this particular global minimum. So that's what we have identified and this works well. So this is the gradient descent. Now that we understood like what does it mean, now let's go back to understand what is adam algorithm. So adam algorithm is nothing but it's called adaptive moment estimation. So it involves a combination of both momentum and root mean square propagation. So uh, now let's try to understand it. Now that we know a gradient descent is to find the global minimum, right? So we understood that, and to control the rate of gradients descent in such a way that there is a minimum oscillation when it reaches the global minimum. So while taking big enough steps so as to pass the local minimum hurdles along the way. So now let's go back to that same graph and so on. So uh, let's assume something like this, like something the graph goes like this. Okay, uh, so this is a local minima, this is a local minima, this is a global minima. So our gradient descent must be smart enough to skip this local minima and find the global minima in a large steps so that it does not need to check every single small steps, that it does not get stuck in the local minima. So that's optimization step. So that's called momentum, and the momentum actually ensures that we don't get stuck in the local minima and we take large enough steps to find the global minima for it. And root mean square propagation actually is an adaptive machine learning algorithm. So if you find time, you can just learn about these two to understand Adam algorithm much more better. So now that the optimization is taken, we have chose the loss function and we have chose the optimizer to make sure that the loss function performs better and the metrics has accuracy. Now we compile the model, and when the model is training, what happens is like we feed the model with the training data and the model tries to learn the associate between the image and labels and we verify it, right? So this is what we have done in today's session, which is like what is the image processing, and we try to solve this particular by using after training we try to predict it, and we have done the same. So to summarize today's session, what we have done is like we have learned what is image processing and the concepts involved in it, and we understood like why it is important in current session today's world, and what are the challenges that we face while implementing the same, right? So there were a lot of challenges which is involved in correction of that images and pre-processing and stuff, and then we understood what are the steps which is involved in an image processing problem, which is a collection of the data and so on. So we learned about the machine learning steps. We identified a particular data source, we collected a particular data source and worked on it, and then we loaded a particular model in an efficient manner. So we used it a TensorFlow dataset load, and we standardized the model using dividing by 255 on today's session. We created a simple CNN model, so which is nothing but a convolution neural network, which has 3 layers, which is flatten, dense, and the output layer. And we learned about like what are the optimizer and loss function, and we created that particular CNN model. So to learn, so we have come to an end of today's session, and we will carry on to see on the part 2 to learn much more better of improving our CNN model to give a better result, and then we'll try to optimize it and build it as well. So the source code and the presentation desk is available in my GitHub code. And if you have any question, please drop in the YouTube chat box and I will reply to it. If you like to connect with me, these are my social handles, which is LinkedIn and Twitter. You can reach out to me at Vivek0712 and Twitter at Vivek Raja 007. My GitHub is Vivek0712. And usually write blogs in both Medium and Dev2, and I'm actively working in these developer communities. You can reach out to me. And if you have any queries regarding my startup or work related queries, reach out to me at nexstem.ai. And thank you.